In this video, I'm going to talk about polar coordinates, and then I'll talk about how to go between polar coordinates and rectangular coordinates or Cartesian coordinate system. Let's consider this xy plane, and on this plane I consider a point which we label as O, and then we consider a horizontal line, okay, x. Now any point on this plane, let's call it P, is identified by two things. One is its distance, which we call radius, from the origin. And the other is the angle that line segment makes with the horizontal axis. We label it as theta. So point P is uniquely identified by two coordinates in the polar coordinate system. One is the radius r, and the other one is theta, the angle it makes with the horizontal axis. Now this point O, it's called pole, or sometimes also called polar origin. Polar origin. And this horizontal axis is called polar axis. And then this r and theta, they are called polar coordinates. Now, this is how you'd identify a point in the polar coordinate system. Now, how do you go back and forth between polar coordinate system and our familiar xy plane or rectangular / Cartesian coordinate system? It's rather quite easy. So let's do this. Let's draw a vertical line right here, and let's call this point A. Now, if you look at the triangle OAP, this triangle is a right triangle, meaning this angle is 90 degrees. The point P in our rectangular coordinate system, so let's draw a vertical axis or y-axis. In the rectangular coordinate system, point P would be identified by x-coordinate and y-coordinate. So this vertical distance is y, and this horizontal distance is x. Now, triangle OAP is a right triangle, so we could use the trig identities here. In triangle OAP, sine of theta is opposite over hypotenuse, and opposite is y, and the hypotenuse is r. So opposite is y, this height, and the hypotenuse is r. I could write y as r sine of theta. Similarly, cosine of theta in that triangle would be adjacent over hypotenuse. Adjacent is x, so x over hypotenuse is r. So we could write x is equal to r cosine of theta. So this relates x and y with r and theta. Then also look at this right triangle. Using the Pythagorean theorem, we could say that x square plus y square is equal to r square. So that relates x and y with r. Now there is yet another thing we could do. In this triangle, we could say tangent of theta is opposite over adjacent, or y over x. Or we could say theta is equal to tangent inverse of y over x. Using these relationships, this, and this, you could go back and forth between the polar coordinates and the rectangular or Cartesian coordinate system. And it's very easy to go from one to another. I hope that this discussion was helpful. Thank you very much.